Hey students, let me try another video solution here. I got a couple questions here about number 48, chapter 6, as you're getting ready for the exam. Here it says, two objects, one moving north and the other moving east, collide and stick together. Now, let me pause right there, because one of the hints I was trying to give you, if you ever came across a scenario where you have two objects hitting, colliding, bouncing off each other, grouping those two objects together is a conservation of momentum problem, okay? And so this one, as soon as I hear this word collision, I think, oh, use the principle of conservation of momentum. Put the two objects together. So it shows here in the picture that one is moving north. And so the picture shows an object of mass m moving north. And so it's got a speed of what they call 2v. Where they show the other object, so let's say they're going to collide right about there. The other object here has twice the mass, but it's only moving with a speed of v, so half as much, okay? And if I pause here and think about momentum, I might say, well, there's an x direction and a y direction. And so the east-west direction, and so in this case east, would have a momentum of the mass times the velocity, so that's 2mv. So there's twice the mass and times v. Now, in the y direction, it would be the same thing. I would multiply by the mass and the speed, which is 2mv, which, other than the order here, hopefully you see that these are the same. And so these two objects have the same numerical value of momentum, one in the vertical direction and one in the horizontal, or in this case east and north. But keep in mind then they have the same xy momentum. Now, of course, they stick together, and that's really the key to the problem. Is then this one says if the eastbound object has twice the mass and the initial speed is half as much as the northbound, which of the indicated paths represent the most likely final motion of the pair? And justify your answer with the concept of linear momentum. So where would they go after the collision? Would they all go due north because that one's going faster? Well, the answer would be no. No way, because if that's the case, then you would have all the momentum in the y direction and you couldn't have any value in the x direction, and so you couldn't conserve momentum in the x direction. And so they label that as A, and so that's impossible. And the same reasoning for E. You can't have E as the direction as the combination. In fact, they stick together. I'll just say it's 3m. You can't go completely in the x direction. You might say, well, it has more mass, it's going to go in that way. Well, no, definitely not, and not completely. It can't, because again, if you go that way, which would be a momentum in the x direction, so maybe you could make this match, but you can't get the y direction to match. You don't have any momentum in the y direction. See, when we have to conserve momentum in both x and y. So that tells me it's got to be something more off in a combination of both x and y. And of course, the options here are B, C, and D. Now, again, knowing a little bit about this idea of vectors, that's what I've said. We've been dealing with and talking about vectors. Did a lab last week on vectors to kind of get us a feel for this. And coming back to here, I need some kind of motion that is basically saying however much momentum it has in the x, it also has the same in the y. So if I were to draw a triangle that had the same length in the x as the y, it would come off at a 45-degree angle. And that's what this would have to be then. I would have to have some kind of motion that would have equal amounts x and equal amounts y. And that means I can rule out the B or the D. See, the B, if you kind of look at it, has more in the y direction than the x direction. So that's not going to work. And the D, if you break it into its horizontal and vertical pictures, the horizontal is more than the vertical. What we need is C, where we have the same horizontally as vertically. And so the only one that makes sense according to the principle of conservation of momentum would be C. And so C is the correct answer. All right, hope that helps.